Hello again. Thanks for watching this video and studying math section with me. This constitutes today's lecture. 2 full chapters of the 5 that you, or I guess it's 7 that you cover in 0481. So it is important that you first probably read your book, including the examples, and then watch this video by stopping, rewinding, and playing and looking at the answers that we do. And realize that additional assistance is a few steps or a few clicks away if you need assistance on any of these topics. We are talking about the rules of exponents. There's a product rule where when you have the same base, the exponents add. Here's another power rule. And here you have the exponent of m distributing to the two factors, and here you have the exponent of m distributing to the top and the bottom, and you can never have a 0 on the denominator. Another rule that you have is that if a is not 0, a to the 0 is equal to 1, and 0 to the 0 is undefined. So the first example, we're to simplify each expression using the product rule. Here are the answers. Note here that a minus times a minus is a plus. The next example is using the other product rule, and here you assume all variables represent non-zero real numbers. That means we don't have to worry about having a 0 in the denominators. Here are the answers that you should come up with. Again, here the 4 is distributed to both factors, so it's 2 to the 20th, a very large number. Times y to the 12th. Again, simplify, assume all variables represent non-zero real numbers, so we don't have to worry about this being 0 or that being 0. And these are the answers we get. Again, minus times a minus ends up being a plus. Example 3 is about the definition of a to the 0, so we're to evaluate each power, and we simplify the answer. So here the base is 8, and so that's just simply 1, and similarly here the base is minus 3b to the 8th, the whole of the parentheses, so both of those are equal to 1. Here the base is minus 8, and so that is equal to 1. But here the base of the 0 exponent is 8, that's minus 1, and here the base of the 0 exponent is the minus 8, so you get 1, but the minus is there. So the answer is minus 1. Here we are to identify each of these as a polynomial or not a polynomial. And for each polynomial, talk about the degree and talk about if it's a monomial, binomial, trinomial, or none of those. So here are the answers. The first two are polynomials because they satisfy the definition of polynomial. This is not a polynomial because we have the y is in the denominator, not in a numerator. The degree here, the highest exponent is 5. The highest exponent here is x to the 1 times y cubed. If I add those together, I get 4. So that is a 4th degree polynomial. This has 3 terms. It's a trinomial. This has 2. It's a binomial. And these questions don't make sense if it is not a polynomial. Here we are to add or subtract polynomials, so we simplify these expressions using the properties we've studied previously, and we collect like terms. Like terms have the same exponents and the same variables in them. So these two examples have, when we simplify, collect these answers like terms. Again, we're to add or subtract. Now here, like terms, we're collecting the terms that have r cubed s to the 6 together. R to the 6s cubed is a different term. And so that's the answer you get at the end of that problem. Here is another example. Here we first distribute the 6 and distribute the minus 4 before we collect like terms. And we get this as an answer at the end of the problem. Here we multiply these together. Now here's what we're doing is we're distributing 4t minus 5 to this one, 4t minus 5 to this one, 4t minus 5 to this one, and then simplifying the result. We can also stack this and multiply it that way. And here I show you both ways. Here's where I do the distribution, and here's where I stack them and multiply them, putting like terms in columns under each other. And you see that there is my answer to example 6. One technique that sometimes is talked about is the FOIL method, and here what you do is you multiply the first elements of binomials and the last element of binomials, and you add it to the sum of the outer and inner products. And so this is described here and on page 20. So for finding this, we're going to have 28 y squared. Here we get 12, and this is minus 35y, so that ends up being a minus 23y minus 15. This one we can also FOIL, but notice that here the inner term is plus 66, here it is minus 66, so they cancel out. So at the end of the problem we have this answer. This example, first we're going to multiply these two together and then multiply them times this x cubed throughout. Now when we multiply this, notice that this two terms are going to give you minus 10x. This is going to give you plus 10x, so those will cancel out, and so we get the first step, and then we distribute that, and we get that as a final answer. Now those are patterns, and you can see that anytime I have x plus y times x minus y, I will get that. And if you think about what this means, you're going to get that x plus y whole squared is x squared plus 2xy plus y squared, and similarly for the minus, except the sign will be a minus. You don't have to memorize these, but it will perhaps make you work faster if you do. So here are some examples. All of these are the form something minus something times something plus something. These are the answers that you get at the end of those problems. Now here we have the plus and the minus examples of those special forms. And here's what we get as an answer. Notice here that 3 times 8 is 24. 2 times 24 is 48. Here 5 times 12 is going to be 60, and 2 times 60 is 120. Now here we have this thing plus that, and the same thing minus that. So this really is two steps. The first step is we notice that this is going to be a squared minus b squared, but then we have to square this, and so we do that, simplify, and that is our answer. Here we have something raised to the 4th power, and the key to doing this problem is realizing that is this one squared times this one squared. So both of those end up being a squared minus 2ab plus b squared, and so we can multiply those in a stacked fashion and get this answer. Here's the same thing, except it's cubed. So what we're going to do is square this one, and when we square this one, we're going to get this, and then we multiply it by s plus 4t, and I stack them, multiply them here, and get that answer when it is simplified. Now this is involving long division of polynomials, so we're dividing this by this expression. This one goes on the outside, this one goes on the inside, and we go through and do the division. Notice at this end I get minus 10, and 3n does not go into minus 10, so that is the remainder. So this is how we write the full answer to that problem. Sometimes you have missing terms, and by missing terms I mean we don't have an x cubed here and we don't have an x here. It's useful to put those in 0. So here's the 0x and that. You don't have to do this, but this helps you keep track of things. Notice that we reach this point where x squared is not going to go into 7x, so that constitutes the remainder, and that is how we write the answer. So in closing, remember, time is precious. Each day must count. Doing the math will make you strong. Take care, and I will see you in class.